Hey everyone, in this video we're going to do some factorizing. So a little bit harder than expanding because it does require a little bit of thinking about what your common factor is, and they do get quite hard. So we're going to start off with some easy ones, but in C and D they can get a bit tricky. All right, so let's just have a look at question 2. So I'm just going to start with an easy one just so we can refresh our memory on what factorizing is. So we look at our two terms. So we've got 3x and negative 18, and we've got to look for a factor, and it should be the highest common factor for 3x and negative 18. So you're doing both the coefficient or the constant number, the number part, and the pronumeral part. So x is only in one term, so that's not common. And then we've got 3 and 18. So 3 goes into 3 and 3 also goes into 18. So I'm going to take 3 out as a common factor. And then we're left with x minus 6. So inside your bracket, you can say, well, what do I multiply 3 by to get 3x? And what do I multiply 3 by to get negative 18? So that's where the negative 6 comes from. All right, let's try a harder one. Let's do F. Okay, so remember you should be doing every question. I'm not doing every question, otherwise these videos will go forever. Yeah, but hopefully you're doing these questions that I'm doing as I'm going, and then either finishing the whole of question 2, for example, before moving on, or doing the whole video and then going back and doing the other questions. All right, so in question F, we've got negative 4y minus 2. So you can take out negative. All right, so you can see both terms have a negative. And then we've got 4 and 2. So 2 is common to both 4 and 2. All right, so what do we multiply negative 2 by to get negative 4y? So it's going to be 2y. And then what do I multiply negative 2 by to get negative 2? Is just 1. Now, obviously you can take out 2, positive 2 as a common factor. Doesn't really matter, but usually we make whatever inside the bracket the easier thing to deal with, and sometimes negatives make things difficult. Now, if you ever want to just quickly check your answer, and it's a good idea too, just quickly expand. So negative 2 times 2y, negative 4y, negative 2 times 1 is negative 2. Awesome. All right, let's do R. So 2x squared yz minus 4xy. All right, so for this one, we've got quite a few things going on. So let's have a look at our coefficients first. We've got 2 and we've got negative 4. So one's negative, one's positive. I'm just going to take out positive 2. Then we've got x squared and x. So x is common to both, and y. So y is common to both, and we only see z in one term, so it's not common to both. All right, so what do I multiply 2xy to get 2x squared yz? All right, so I've got an extra x there, so I've got to put that in, and the z. And then the 4xy, we're going to have minus 2. So just a quick check will help you realize whether you've factorized it properly or not. All right, moving on to question 3. So question 3, instead of having a common factor that is, I guess, just a term, a single term, what we've got now is a common factor that is a bracket. So you can see each term has an x minus 1. So all we do is take out x minus 1 as a common factor, and then whatever that is multiplying that bracket is what we're left with. So 5 minus a. So with this question here, because I haven't actually done any G to I, I'm going to put one in that's an example of that. So I'm just going to make one up. Let's do a times x plus 2 minus x plus 2. All right, so you can see brackets are the same. So that means x plus 2 is a common factor. And then what is multiplying those the x plus 2 bracket is just going in the other bracket. So we've got a, and don't say a minus 0. That's not a 0 there. If it was a 0 there, that bracket wouldn't exist. It's a 1. So it's a minus 1. All right, so that's what it meant. So if there's nothing, oh, sorry, I shouldn't say nothing multiplying it. If there's no number there, remember it's always 1 times the bracket. All right, question 4. So this is an example of difference of perfect squares. So when we did the expanding, remember I spoke to you about that. So we've got x squared minus 9. So I'm going to write the rule again, but just the other way around, because this time we're factorizing, and factorizing is like the opposite of expanding. So when we've got a squared minus b squared, that's going to factorize to a plus b, a minus b. Okay, so all you need to do is identify a and b. So a is just going to be the square root of your first term. So in this case, it's x. And b is just the square root of the second term. Now, it's not, don't see it as -9 because your difference of perfect squares already has the negative, probably can't see that too well in yellow, already has the negative there. So we're just going to see the b squared as 9 or 3 squared. So the square root of 9 is 3. So when you're writing your factorized expression, x plus 3, x minus 3. Let's do another one of them. Okay, let's do b. X squared minus 25. So again, identifying what a and b is and using this rule. All right, so a is just the square root of your first term. So in this case, it's just going to end up being x. And b is the square root of the second term, which is 5. So then it factorizes to x plus 5, x minus 5. You can always check it by expanding as well. All right, which question are we doing? Question 4. Let me just check the other ones. Oh, let's do J. 64x squared minus 25y squared. So a is the square root of the first term, so 64x squared. So the square root of 64 is 8, and the square root of x squared is x. Then b is the square root of your second term, so 25y squared. Square root of 25 is 5. Square root of y squared is y. So then we're just going to have 8x plus 5y, 8x minus 5y. All right, question 5, we're also going to be using difference of perfect squares. So a little bit more practice, which is great. Now, if you get an expression to factorize and you look at it and you're like, oh, that doesn't look like perfect square because 32 isn't a perfect square and 2 isn't a perfect square. See if there's a common factor first. So we're going to take out 2 as a common factor, and then inside your brackets, I'm going to be left with x squared minus 16. And then you can see inside your bracket, difference of perfect squares. So a is going to be the square root of x squared, which is just x, and b is the square root of 16, which is 4. So we keep the 2 out the front, but we're going to have x plus 4, x minus 4 in brackets. All right, let's do another one from question 5. Let's do F. 3a squared minus 300b squared. So again, 3 and 300 are not perfect squares, but we can take out 3 as a common factor and just see what happens. All right, so 100 is a perfect square, which is awesome. So we can take the square root of a squared, which is a, and the square root of 100b squared, which is 10b. 3 stays out the front, and then we're just going to have a plus 10b, a minus 10b. Okay, so taking out the common factor first. All right, also in this one, so let's do some with some brackets because they are a little bit harder. So let's have a look at m. So we've got 3x plus 5 squared minus x squared. All right, so taking the square root of your first term, and your first term in this case just happens to be a bracket that's squared. So I should write a equals. Now, that square root sign cancels out with the squared sign.
Queensland needs tradies in paradise. Join us now.
Don't know why that started playing, but anyway. So the square root just cancels out with your squared, and you're left with 3x plus 5. We're not taking the square root of what is inside the bracket. That square root cancels with the squared sign. All right, so I kind of feel like some students will make that mistake. The square root and the square cancel each other out. What stays inside the bracket, what is inside the bracket just stays the same. All right, and then b is just the square root of x squared, which is x. All right, so bringing that all together, we've got our a, so 3x plus 5 plus x, our b, and then our a again, 3x plus 5, then minus b, so minus x. And you can see we've got some like terms here. We've got a 3x and an x, 3x and a minus x. So we're going to have 4x plus 5, and then 2x plus 5. All right, let's do another one like that. Let's do n. So 2y plus 7 squared minus y squared. So a is going to be the square root of 2y plus 7 all squared. Now remember, the square root cancels out with the squared, and we're just left with 2y plus 7. And b is the square root of y squared, and that's just going to be y. So let's bring everything together. So we've got 2y plus 7 is your value of a plus b. And then your a plus b again, a minus b, so minus y. All right, so we've got 2y plus y is 3y plus 7. 2y minus y is y, and we've got plus 7. All right, how many more questions have we got? Quite a few to do. All right, let's move on quickly. So question 6. Now, in question 6, you'll notice that we don't have perfect squares. So for 6a, for example, we've got x squared minus 7. So 7 is not a perfect square. So we just need to leave it as a surd. So a is the square root of x squared, which just becomes x, and b is the square root of 7, and we can't simplify that, so we just leave it as the square root of 7. But it's the same deal. A plus b, which is x plus the square root of 7, and then a minus b, so x minus the square root of 7. Let's do another one. All right, so a is the square root of x squared, so it's going to be x. B is the square root of 18. Clearly. All right, so 18 isn't a perfect square, but we can simplify it. So we look for a perfect square that goes into 18, which is 9. So that becomes 3 root 2. All right, so you should be simplifying your surds. So we get x plus 3 root 2 times x minus 3 root 2. All right, let's do a harder one again. So let's do n. X squared minus 48 So a is the square root of your first term, so it's just x, and b is the square root of your second term. All right, so 48 is not a perfect square, so you've got to think of the highest square number that goes into 48. All right, does 16? Yes. So it's going to be 16 times 3, which becomes 4 root 3. So when we factorize it, it's going to be x plus 4 root 3, x minus 4 root 3. And it's extremely important that you get used to surds because you're going to be seeing them a lot. All right, and it's extremely important in maths that you don't round, that you don't, have a decimal answer that you round, because, if you're building a bridge and you start rounding off numbers, your bridge is going to fall down. So you've got to get used to having exact values. All right, so we've got x plus 1 squared. So remember, your bracket cancels, sorry, not your bracket, your square root cancels with the squared. So we're left with x plus 1. And b is the square root of 19. Can't be simplified. So we're going to be left with x plus 1 plus square root of 19. And then x plus 1 minus square root of 19. You can't, you are adding 1 and square root of 19, but you can't bring them together. You just leave it like that with a plus sign in between. All right, question 7. Now we're doing a bit of grouping. So question 7 and 9 are very similar. The only difference is question 7, they're already put in the correct order for you. But in question 9, they're not. So we're going to have to do some rearranging. And it does say in the question that we need to rearrange it. So what it means by grouping is we've got 4 terms and we're going to put them in pairs. So we're going to do, there's a pair and there's a pair. I'm just going to look at these pairs separately. So I'm going to factorize x squared and 4x first, and then I'm going to factorize ax plus 4a. All right, so let's look at the first pair. So x squared and 4x, common factor is x, and then I'm left with x plus 4. And then in my second pair, a is your common factor, and then we're left with x plus 4. Now don't forget there's a plus sign in between, so I've just put my plus there. Now we've got what we had, I think, in question 3. Our common factor is a bracket, so we're going to take out x plus 4, and then x, what we're left with, x plus a. Let's do another one of them. Let's do G. So we've got x squared minus ax minus 4x plus 4a. All right, again, doing our pairing. Okay, so looking at the first 2 terms, what is common? We've got x, so we're going to be left with x minus a. Now, if we're doing factorizing by grouping, obviously you want the other bracket to be x minus a. And this is where it can be sometimes difficult with negative numbers. All right, so I want to get negative 4x, and I've got a positive x here. So that means I'm going to have to multiply it by negative 4. And then just check your other term. So negative 4 times negative a. So a negative times a negative does give you a positive, and it's 4a. So awesome. Now we've got 2 brackets that are the same. So they are our common factor, and we're left with x minus 4. All right, in question 9, let's just write the whole thing. Xy minus 6 minus 3x plus 2y. All right, if I were to do grouping, you can see there's no common factors in those pairs. All right, so you might come across a quadratic that you need to factorize, and you're like, oh, I can't do it by grouping. There's nothing in common. So what you just do is you switch. So I tend to just switch these 2, and I don't know why. I just always have. But you can also switch these 2. All right, just changing the order. So I'm going to do in green, the first one, and I'll show you why you can do any. So xy, so instead of the minus 6, I'm going to have plus 2y. And then I've got minus 3x minus 6. All right, so let's do our pairings. All right, so the common factor for x, y, and 2y is y, and then we've got x plus 2. That means in my second one, I've got to have x plus 2. All right, so that might help you with your negatives. All right, so negative 3, just double check. So negative 3 times x, negative 3x, negative 3 times 2, negative 6, awesome. So that means x plus 2 is your common factor, and then we're left with y minus 3. All right, I was going to do the blue way, sorry, before we move on. All right, if I had rearranged the negative 6 and the negative 3x, I'm just going to put a line down there. So xy minus 3x minus 6 plus 2y. So still going to do our pairings. All right, so the common factor for the first one is going to be x, and then I'm left with y minus 3. So that means in my second one, I should have y minus 3, but let's just wait and have a look. All right, so I'm going to take out 2 as a common factor, and then I'm left with negative 3 plus y. Now, this moment it looks like they're not the same, but they are. They're just written around the other way. So I'm just going to write them so they're both in the same order. All right, so they're the same. Y minus 3 comes out as your common factor, and then we've got x plus 2. And you can see they're the same thing. So even though they're around the other way, they're still equal to each other. It just means the green one, I had x plus 2 as a common factor, and the blue one, I had y minus 3 as a common factor. But it doesn't matter because you get the same answer. All right, maybe we'll do one more. Let's do F. Two ax minus 20 plus 8a minus 5x. All right, so it doesn't matter which ones you switch, but I am going to stick with the way that I always do it. So I've switched the these two. All right, so grouping. All right, common factor for 2ax and negative 5x, that's just going to be x. So 2a minus 5. That means I want 2a minus 5 in the next one. What's your common factor? What is it, 4? 2a minus 5. So 2a minus 5 comes out as a common factor, and then we're left with x plus 4. All right, I'm going to leave it there. Bye.